Here's a question. How do you read a Roman numeral like XII as a number? 12. 10 plus 1 plus 1. Easy. But what about IV? That's 4, not 5 plus 1. Why? First, the table. 7 symbols, each with a value. I is 1, V is 5, all the way up to M at 1,000. An easy one XII is 10 plus 1 plus 1, 12. Stack symbols, add values, done. But here's MCMXCIV, 1994. That's not a clean sum. Where do those gaps come from? The trick: when a small symbol sits before a bigger one, it gets subtracted. IV is 5 minus 1. CM is 1,000 minus 100. What would you try first? Walk left to right, look up each symbol, add the values up. Should work, right? Let's try MCMXCIE. M is 1,000, plus C is 1,100, plus another M is 2,100, already overshooting. The real answer is 1994. We needed to subtract that C between the two as, not add it. So a plain left to right walk doesn't know enough at C. We'd need to peek ahead at the next symbol to decide add or subtract. The rule isn't use this symbol's value. It's use this symbol AND, the next one together. The decision lives in two places at once. Pause here. The mess is that any symbol's contribution depends on what comes after it. We're stuck looking forward at every step. What if we flip the direction? Walk right to left. Then what comes after is something we've already seen, sitting in memory. Now the question is simple. Is this symbol smaller than the last one I saw? If yes, subtract. If no, add. Remember integer to Roman? A table flipped a pile of special cases into a simple loop. Same trick now, going the other direction. Symbol back to value. You might think you need pairs, like CM, maps to 900, IV to 4. Don't. Single symbols and one comparison handle every case. And the rule prevents a bug. If you forget to compare and just add, IV becomes 6 instead of 4. Compare first, then add or subtract. Okay, let's walk MCMXCIE. Right to left. Total starts at 0, and we'll remember the last value we saw. Rightmost is V, 5. Nothing seen before, so we add. Total is 5. Remember 5 for the next step. Move left. I is 1. 1 is smaller than 5, so subtract. Total drops to 4. Now remember 1. C is 100. Compare with 1, bigger. So add. Total jumps to 104. Remember 100. X is 10. Smaller than 100. Subtract. Total drops to 94. Remember 10. M is 1,000. Bigger than 10. Add. Total is 1,094. Back to C, 100. Smaller than 1,000. Subtract. Total drops to 994. Last symbol. M is 1,000. Bigger than 100. Add. Total lands on 1994. Done. Notice what just happened. We never peeked ahead. Each symbol only used the one we just saw, already in hand from the step before. One pass over the string. The table only ever holds 7 entries. Time grows with the input length. Memory stays fixed. Same logic in Python. The values table is just a dictionary. We track the running total and the previous symbol's value. Walk the string in reverse. Each step, look up the current symbol in the table to get its number. Now the rule. If it's smaller than what came after it, subtract. Otherwise add. Then remember it for the next step. Once every symbol's been visited, hand back the running total. And that's the move. When the rule depends on what's coming next, sometimes the cleanest fix is just to walk the other way.